The title of this paper is Holding AI to Account: Challenges for the Delivery of Trustworthy AI in Healthcare. It is published in a special issue of Transactions on Computer-Human Interaction on AI in Healthcare, Challenges Appearing in the Wild. My name is Rob Procter, and the co-authors are Mark Rouncefield and Peter Tolmie. The need for AI systems to provide explanations for their behaviour is now widely recognised as being key to their successful adoption in a wide range of application domains. In this paper, we examine the problem of trustworthy AI in the context of healthcare decision-making and explore what delivering this means in practice. The findings documented in the paper are from a series of ethnographic studies of decision-making in healthcare. Ethnography focuses on how work is actually accomplished and is therefore indifferent to theoretical or organisational stances on how work should be done. It is widely used as a tool for gathering requirements for the introduction of digital innovations into new work settings, and our aim was to understand what requirements an AI system should satisfy if it is to be trusted by its users in healthcare decision-making. The focus of the study was the breast cancer care pathway. This typically consists of a mammography stage that is designed to identify the very early stages of cancerous changes. If these are detected, the patient will be sent for a biopsy, and this will then be examined in the histopathology stage of the care pathway. Finally, depending on the findings of the mammography and histopathology stages, a multidisciplinary team meeting will decide on what the treatment option should be for the patient. Turning first to accountability and mammography, we see in this slide the reporting form used during the mammography stage, in which two radiologists examine the mammograms independently and record their decisions about the presence or otherwise of cancer. They do this by annotating the screening form, documenting what they have seen and its significance as a potential diagnosis. These annotations therefore provide an explanation of the decision the radiologist has reached, and they are designed to be understood by anyone with a shared understanding of the work of reading mammograms. It shows how radiologists orientate towards being accountable, and their recognition that the grounds for being trusted by their colleagues has to be reproduced in and through the work itself and is not taken for granted. Next, accountability and histopathology. In this extract, a histopathologist talks about how they record the decisions having examined the histopathology specimens. She says, "Trainees will describe all of these features. And the more experience you get, you cut to the chase more, and you don't include all of that. I will include things like that if I found it very difficult to come to a decision. I'm giving an indication of how sure I am about something. I might have shown it to several colleagues. These are the things we've taken into account, and this is the conclusion we've come to. But if it's a really straightforward case, if it's been very easy and quick to get to the crux of the matter, then I wouldn't put all of that in a report." So this illustrates what is considered to be an adequate account is subject to a number of different considerations, including how difficult it has been to make that decision, and in a difficult case the histopathologist will carefully lay out the reasons, and again this is about being accountable to other professionals who may see that decision. Finally, accountability and multidisciplinary team meetings. Here the collective expertise of healthcare professionals is brought to bear to decide on a treatment plan. Those involved include radiologists, histopathologists, surgeons and nurses, and they work together to provide a sense of what different accounts in radiology, histopathology reports, etc. amount to. Multidisciplinary team meetings are therefore all about accountability, and at any point in the meeting those present may be required to provide accounts for their decisions. We now turn to some case studies of the use of AI systems in healthcare decision-making, focusing on how healthcare professionals orientate to calibrating their trust in the AI system with whatever resources, indeed if any, are provided to account for its behaviour. Here we see an AI system for mammography, which used prompts to draw attention to areas in the mammogram that were potentially suspicious, but no explanation of why. Here's an extract from what one of the radiologists commented on when viewing and making sense of the output that the system was presenting to them. The radiologist says, "I've seen this before. The computer's marked something that I think is an artifact on that side. It's along the edge of the film." What we observe here is radiologists' trust in the AI system being based on accumulating observations of its behaviour, what we refer to as a system biography. The radiologist is clearly reflecting on a similar occasion when the system produced this particular kind of output. Such an informal biography of a system is not necessarily going to be completely accurate, of course, and so there's a need for the system here to provide accounts that are tailored to particular behaviours observed, and which will then be a material resource for the accounts radiologists are themselves expected to provide for their decisions when using the system. Turning now to an AI system for histopathology, here we can see an example of the output that it produced, including a marker where the system has identified what it has determined is a cancerous lesion. Again, the system provided no explanation of why. Here we see comments made as 3 histopathologists reflected on the behaviour of the system. Anyway, it's kind of easy once you know it's like T4 with metastatic disease to go for a higher grade, isn't it? But I thought the other part was interesting. So you can see that parts are not flagged as suspicious, but that's cancer, I think, and that's why I called it. I mean, that's unusual for it, meaning the system, to miss it, isn't it? So what we see here is an extract from an ongoing calibration of how trustworthy this particular system is, identifying examples of where it misses cancers. More generally, what we conclude from these studies is that accounts provided by an AI system should match the characteristics of specific cases. There should be a choice of techniques for accountability that can be used sequentially and or in combination if that is necessary to arrive at an unambiguous decision about whether the system's behaviour is trustworthy in any given case. The example of an account shown here is based on a heat map showing areas of the X-ray that were particularly significant to a system for a particular diagnosis. Accounts should also reflect decision-making practices. Sometimes, for example, we observe that histopathologists will note that the case they're looking at is similar to cases they've seen before. So comparing the current case with previous cases may be helpful. This takes us back to the issue of a system biography noted in the mammography study. What we conclude from these studies then is that it would be valuable to have a repository of previous cases. That is, an up-to-date account of AI system performance that will allow comparing performance on previous cases to help decisions on a current case, that will record how system accounts are used in decision-making to support collective learning of the strengths and weaknesses of the AI system, and provide the means to audit the system to detect changes in performance that might put patient safety at risk. To provide a little more detail, this is what we envisage a system biography would provide. Here are a series of use cases. First, when seeing a new case, a variety of types of system accounts, explainability methods or XAI methods are made available to the user to choose from. Next, in making a decision, the user may decide to extract cases from the repository of previous cases that are similar to the one that they're looking at, to see if there's a pattern in system behaviour that might be helpful in deciding on the current case. Third, when the decision is made, a record of which system accounts were used, how they were used, and what the user made of them when making a decision is added to the repository as a component of the account of how the decision was made. Next, in multidisciplinary team meetings, the system biography allows for accounts to be retrieved and presented to all members of the multidisciplinary team so that they can see the evidence base for the eventual decision and the role of system accounts in making it. Then there is collective learning. The system biography is a resource that captures actual system use that can then be consulted by trainees when they are learning to use a system, including learning about its strengths and weaknesses. Finally, the system biography provides the means to audit the AI system, that is, to detect changes in performance that may occur over time, that may therefore be of concern and would need to be addressed. Moving now on to conclusions. First of all, AI systems should be accountable throughout the care pathway, and their accounts should be recipient designed, matching the needs of different users and the context in which they are being used. And the implications of this for the types of system accounts and their design need to be thought about very carefully. More generally, it is clear that the introduction of AI systems will itself shape how healthcare professionals make themselves accountable for their decision-making. Resources for AI system accountability will therefore need to evolve. This will need to be supported by sharing experiences, best practices, and by training. And new competencies may be required of healthcare professionals, and new roles created. Healthcare organisations will need resources and the skills to conduct regular auditing of AI system performance. A new trust architecture will be required, beyond what is already in place in healthcare, blending human skills and technological components in ways that will ensure that trust in the overall decision-making process, a combination of healthcare professional expertise and AI system performance, can be sustained. Our future work will include doing more ethnographic studies to address what trustworthy AI means within particular work settings. There are significant benefits if findings of ethnographic fieldwork can be made to be reusable, and with this in mind we will be aiming to develop a toolkit of methods for articulating trustworthy AI requirements and linking ethnographic findings to design issues and identifying what we refer to as design patterns for trustworthy AI that can be reused in different settings. Thank you.